I'd like to welcome you to the official Jacobs living room.
Except we didn't bring my mom.
Your mom's not here. I thought Joan would be here.
She was supposed to.
Very happy to have Irwin and Paul with us today. And Sharon Anderson Morris gets a lot of credit for helping put this together. We've had each of you separately, and so it's kind of cool to have you here together. And I think of it as a bit of an event. I understand this is the second time in history you've done this?
Yep.
Mm-hmm. Very cool. FiRe, thanks.
You'll see why after we're done. No.
So I want to start this a little bit informally because of exactly that reason. We'll talk tech and we'll talk about some other stuff in a minute. But I'm kind of curious. Irwin, you did this kind of mind-blowing job of creating Qualcomm, co-founding it and getting it up to where it is almost till now. And I didn't bother reading your background out loud because it takes too long. It's kind of 15
Just
pages
as well.
of awards. And,
right.
Clearly, you did it right. And then I think the odds of having this thing happen where the son comes along and does the hard work, I know what you've been through, and been through every division and engineering, and having that actually work is almost infinitely impossible. So I have a lot of respect for you guys, whatever the difficulties may have been, that you actually were able to make this happen. The number of companies where this happened, I think, are probably one or two, so that I know of. So I'm kind of curious, would you mind sharing just a few informal stories about the experience of doing the handoff and of doing these things?
Well, we have 4 sons, and Paul's number 3, but he was the only one who actually went on and got a PhD in engineering. And one of the things we think is very important for a high-tech company is to have somebody that's well-trained in engineering as the CEO. So Paul was the only son that kind of fit that category.
And you were smart enough to know that.
He could see I got the PhD. He wasn't too happy I went to Berkeley and said MIT, but it was okay. But the thing that he did for me that was amazing while I was growing up was I used to go, so the company before Qualcomm was called Linkabit, and I worked there over the summers, and every summer I got to do a different kind of engineering job. And even, I mean, when I was a kid, I started out like doing drafting and stuff like this. So I even got that aspect of it. And it kind of, by the time I was partway through grad school, I had done basically everything except IC processing. We had done, even IC design, all this stuff. So fortunately at Berkeley, they had a lab above my office, and I got to do IC processing even there. But that's kind of the way that he was. And he's always given people opportunities to sort of rise to the occasion. And I think also, when we did the transition, I talked to Brian Roberts, and he went through a transition like that. And he said to me, exactly, and he said, it's 90% your father. Because, you have to give the kid the room to make the mistakes or do things that you might think are different from what you would do. And you absolutely did that.
But the decision for Paul to come to Qualcomm actually almost broke up the family. My wife, Joan, Paul's mother's not here, but he went off on a postdoc in Toulouse, which was great. But when he was getting ready to come back, there was a discussion, should he go first academic and then industry, or the other way around. And my wife kept saying that, I had gone academic first before industry, so perhaps it would be a good thing for Paul. And I said, gee whiz, Qualcomm needs good people. Here's a good person coming back. We can't afford to lose him. Yeah. And luckily, he made the decision, of course, and decided to come to Qualcomm.
Did that feel right to you?
Oh, no. I mean, I was trying to make the decision between, do I want to do research and present papers at conferences, or, I'd already worked enough, so I had worked on things where other people were using stuff that I had done. Yeah. And I just loved that. I mean, my favorite story is when we did the Palm smartphone, and I was walking with my wife in New York. We were just walking up a street, and somebody behind us had it, and one of the few people who bought the thing had it, and was like really excited about it. Yeah. And I didn't say anything. I just like turned to my wife. I did that. It's like that kind of a thing. It's hard to find those kind of opportunities. So I just felt like going into industry was what I wanted to do, and obviously Qualcomm was the place to do it because it was so exciting.
Right. When you started, when you went from Linkabit to Qualcomm. What was driving your vision? What was driving your mind?
Well, we sold Linkabit in 1980. I stayed on until 85, retired, and after 3 months found retirement wasn't very much fun. And there was still a lot of potentially exciting things to do. And so in July of 85, along with 6 others that had worked with me at Linkabit, we started Qualcomm. But not in the usual traditional way of starting a company. We had no business plan, we had no products in mind, we had no spreadsheet of how things are going to go ahead, et cetera. But we knew wireless, we knew digital would be of interest. And so we started. I told my wife that perhaps we'd get to 100 people. And if things went really well, Linkabit had done much, much better, but that was in the past. But within about 2 or 3 months, came up with the idea of using CDMA for wireless and a few other products. And we've been running hard ever since to keep up with that.
Yeah. And you had to go to that CDMA, TDMA kind of decision process, just like everybody else?
Well, it's interesting that at Linkabit, we developed the first commercial TDMA phone for a company at the time called International Mobile Machines.
Okay.
And
Which is now InterDigital.
so into digital, they switched over. And in fact, a lot of the patents, we did under contract, which again was a lesson. And so they own the intellectual property, and they've done very well with that intellectual property.
Yeah.
Right. But we knew TDMA well. CDMA hadn't really thought about before until we had a contract with Hughes, who was designing a mobile satellite system. And after the second consulting meeting with them coming home, suddenly realized that perhaps CDMA would allow one to use that time period when people aren't speaking for others, so you get a larger number of users in the same amount of spectrum.
We should explain. Code Division Multiple Access is the CDMA acronym. Yeah.
I'm not sure if that makes it any easier.
I don't know if it helps at all, but at least that's
right.
So the way your 3G
TDMA,
phone
which is
works.
time.
Yeah, it's the way we're still using it today.
Right.
Yeah.
And,
absolutely.
And so spectral efficiency and the efficiency of channels and so forth was higher with CDMA.
Right. Had a lot of advantages that we developed over
Right.
time, but many companies had looked at this. Research labs around the world had looked at it and given up. And so when the debate came on how to go from analog to digital, and there was a vote, I think it was January of '89, TDMA won out. And in fact, it was the people that had worked with our IMM, et cetera,
Yeah.
that pressed that as well.
Yeah.
And so 2 months later, we felt that we had to delay going to CDMA. We didn't have the funding at first. We had to get our first commercial product out on the market. Once we had that cash, we went back to CDMA, and it took about 3 or 4 months to really get confident that this was a good technology. We had solved the hard problems, or at least I thought we had solved them, and so that we could go public with it. But it was after this tough vote where people had decided between TDMA and FDMA, time division, frequency division, and so nobody really wanted to hear about code division. So it was a battle all the way to
Right.
get that adopted, et cetera. And of course now all 3G, all third generation is CDMA.
So the challenge you saw when you were launching Qualcomm was that I've got a good team, and here's the world about to go digital, probably.
Well,
And we have these guys who know how to do this. Is that correct?
So, I mean, it's a little bit looking backwards, but if you think about the cost of computation, at Linkabit, they basically did it for military and space, and the beginning of commercial, computation came down, and they could do it for much broader commercial and then consumer.
Right.
And so that was
a big
I
goal.
don't think you thought that ahead of time necessarily, but it was kind of the trend that really
Well,
fueled.
in fact, there were a number of people, AT&T Labs, et cetera, Bell Labs, that argued that CDMA is too complicated and fancy vocoders are too complicated. They're going to run the cost of a phone up. Rather than looking a few generations ahead and realizing that you're going to be able to do all this complicated technology within a chip,
Yeah.
and that won't be too complicated, won't be too expensive.
And you saw that coming.
So we always kind of try to look a little bit ahead. Don't design for today. You have to design for a few years out.
Right.
Like you said about Wayne Gretzky.
Yeah, where the puck's going to be. Yeah. So, and Paul, when you became CEO,
Yeah.
different era entirely. when,
Little litigious era.
the first night or the night before.
No, you can see the difference right here. I'm wearing a tie. His first decision when as CEO was that the ties weren't required.
I'm on his side. I'm sorry.
The funny thing was, so I got elected in March, and I took over in July, and we had the staff meeting. So I come in the first day after the election, and I don't have my tie. And then you see people around the table,
One by one, the ties
one
are-
by one. It was really funny.
That didn't apply to engineers, by the way. Engineers, the only requirement was that they wear shoes.
Shoes.
Oh,
Did
yeah, I'm not
dropped
sure
the
even that.
They probably had pocket protectors when you were starting, and they didn't.
With the slide rule.
Yeah, exactly.
Sorry.
That's fine. I still have a slide wheel button. So when you saw this landscape,
You may still
different
have a
landscape-
wired telephone.
So different landscape, right? So instead of saying the big window, big opportunity is going to be, what did you see when you look at Qualcomm first day of CEO?
Yeah.
What's that big window for you?
So I mean, I had been doing this all through the 2000, and actually while I ran the handset business, even from say '95 on. But the whole notion of the wireless internet and the notion of integrating more and more capabilities into the phone. So the phone was going to be this kind of most personal device for not just communications, but computing and entertainment and all these things. So went off and, I had done the speech coder originally, so I always saw the system sort of as a link for applications to run on either side of. And we had a guy that figured out how to run TCP on top of it, and this was back in
Late 90s?
Yeah, late 90s. Well, no, it was pretty early 90s, actually. I would think it was 90. When did you hold up that big phone? Was that 92, 93 maybe?
93, 94.
Yeah, so
somewhere in
anyway,
there.
so I
Yeah.
had looked at the system from an application standpoint, even more than looking at it from a radio standpoint.
Right.
So that was the transition I thought was going to happen, was
Sure.
that, of course, we still optimized the radio more and more, but then it started to be about all the kinds of things that you could put into the chip, all the integration. That's why we now, we have GPS in there, and now the microprocessor and the graphics and the connectivity and just all of that stuff. And so we did that. And then the other thing that I did early on was, the company was really seen as the CDMA company, and I wanted to make it seen as a wireless technology company. And so we went out and bought very quickly this company called Flareon, which was, in some ways, I mean, maybe a little smaller way, but they were kind of to OFDM, which is, LTE. What Qualcomm was to CDMA, and so
Orthogonal frequency.
OFDM.
Division multiplex, right?
Yeah, so that in one stroke, people went, oh wow, Qualcomm's doing this broader thing.
Right.
And of course, the other thing that happened was we got sued by everybody and their brother, and it was just like, how many lawsuits did we have? It was just crazy. So people
Kind of
really
fun
were
now
trying.
looking out and watching everybody else sue each other, and we've been off to one side.
Yeah, I remember that. And that was over CDMA, wasn't it?
Yeah,
over
all
variety
sorts of
of
stuff
things.
and anti-competitive plan. It was kind of anything they could think of to try and stick to the wall.
Yeah. That brings me to another point that is, to me, a hallmark of what you both have achieved, which is the the pure IP business plan. At a time when everybody was making their own, and I know you've made chips, you've made phones, but at a time when everybody seemed like they're manufacturing the stuff, you seem to very early understand that the value was in the intellectual property. And even when you were getting your hands a little bit dirty, my feeling from the outside was it's a diversion. Really, we're doing this to incent the market or something, but really, we know that we are an IP company, and that's how the future is going to work for us.
Well, actually both, but
Yeah.
the licensing business came up kind of out of necessity. We had them finally demonstrated with some equipment, a mobile phone that required a van to drive it around, that CDMA did work, but now we had to go to chips and be able to have commercial-sized equipment. To do that required a lot of money. And so the question was how to raise that money. The carriers were interested because CDMA did offer much more efficient use of spectrum, and they realized spectrum was a dear commodity. And so they encouraged manufacturers to at least talk with us, and we came up with the idea that we would use a licensing approach where they'd have an upfront payment, and that money would give us the money to do R&D. And then in the very unlikely case that this ever really did become commercial, they'd pay us a royalty on every phone And nobody, I don't think, paid too much attention to
That was
that
small print.
aspect of it. That was right. And so it was essentially in order to be able to continue that we came up with that model. And a lot of people at the time said, that really wasn't a very good model. So in any case, we followed that model. And then we had to reach another crucial decision a little while later when we were making phones. We were actually making some infrastructure and chips. And the question was whether to continue in all three businesses or not. And we're trying to sell the chips internationally to manufacturers around the world. And they would always say, well, you're going to give us those chips and the software 6 months after you give it to yourself. And so it was not quite working well, even though we said, we denied that. And so we had to decide to go ahead and sell that, the phone manufacturing business and the infrastructure business.
You had the Google problem.
What should you keep together?
Yeah.
But we decided that keeping the chip business, that's where you have a new idea, put in the chips, add software, get it out to many manufacturers, and it gets to the market very quickly.
Right.
And so that's worked well.
And I mean, a licensing business isn't very good if you can't get your ideas into the market, so you get that benefit of them being together. And then the IP business allows us to invest very early in new technologies. Even if our product isn't the winning one, we create the intellectual property, we catalyze the market, but the chip business gets access to that technology early. So there's really this nice synergistic effect between those two things. And the handset business, I mean, it is a very brutal business. I mean, there's so many components that you're dependent on. I remember coming in on any given day when I was running the handset business, and somebody'd say, oh, well, we have this problem, it's $100 million to fix it. And of course, by the end of the day, or maybe the next day, for 98% of the time, you fix the problem. But there were times when I walked into a warehouse once, and it was like the end of the Indiana Jones movie where the guy looks down that warehouse, it's just going forever. Well, this one was filled with phones that needed to be fixed. And we just said, this is not really our core competency. And so we had lots of partners, and Samsung back then was a big partner of ours. And we'd work really hard, and we'd figure out our 3 phones we were going to sell to the operators that year. And the Samsung guys would walk in and dump 20 phones down on the table, say, here, pick the ones you want. And we just didn't have the ability to compete at that level on that particular business.
But one of the things you need to bring up or mention is that the first commercial system was in Hong Kong. The next 2 commercial systems were in South Korea. All 3 of those systems use phones manufactured in San Diego.
La Jolla, California, the low-cost labor capital of the world.
Right.
And it still is.
That's right.
All right, so you kind of backed into the IP first strategy. Now that is your strategy. Is that a correct read?
Yeah, I mean, if you even look at the chipset business, it's fundamentally an IP business because we do the designs, but the manufacturing is predominantly done by TSMC and then other third parties.
Right.
So.
Right.
Yeah, it's almost entirely that way. We do have a fab that we're building for Mirasol, our display technology, but that also is just to catalyze the market. The long-term notion is not that we would be manufacturers of displays, it's that we would license technology to other people to manufacture it.
That's what I thought.
And we were very lucky in a sense. We had started working on, everybody was still looking at voice and beginning to move to CDMA, and we were working on high-speed data, and we were realizing that that was going to be the future. And CDMA was very well suited to that. But then how do you get a lot of computing power on a chip? And we began to look at how much energy we're using per cycle, et cetera, and realized we weren't doing very well. Luckily, IBM was leaving that business of designing CPUs on chips, and we were able to hire a group back in Research Triangle Park to help design chips for us. And so we started, I think, rather early in looking how do you get a lot of computing with very little energy being used. And of course that's built up now to the Snapdragon.
Yeah.
That's given you a leverage everywhere you've gone.
Yeah, no, it's been good. And then we got graphics out of, it was ATI, went to AMD, so we jump-started our graphics technology that way. We bought a Theros for the connectivity. So we put some other technologies together as well as all the stuff we did organically.
Right. Well, I think your vision of the original TPI stack on the communications radio was exactly right, and
it was all of ours. I mean, it wasn't just me.
But I mean, maybe it was obvious to you. Probably wasn't obvious to everybody, but it's gone so far that way now that it's flipped almost. Whereas I tend to think of a phone as something which happens to communicate, and by the way, it is every day more like a computer and less like just a handheld communicator.
Yep.
when you are eating your way up the supply chain, which is how I see things happening here, how does it feel? So when you look, I want to see, when you look forward now, my sense is, I watch you guys look at Snapdragon comes along.
Right.
I see you looking at the pad world, and I got to think you're looking at the desktop world at some point.
Right.
So could you lay out the 5-year plan? Like where is Qualcomm 5 years from now? How do you see it?
Yeah, I mean, obviously the smartphones are going to continue to take off. Emerging markets are going to continue to take off. So we're going to push the prices down and get stuff, much more widely spread. So everybody has access to the internet and computation and all that. Right. So that's kind of that's the near term. You see that one right ahead. The one right after that is all the, actually going into the full computing space. So, we've been partnering with Microsoft on Windows RT, which is the ARM-based version of the next generation of Windows. And that's going to be on very small, light devices, like you expect, but it'll have full computing environment, full office, all those kinds of things. So we'll see. I mean, I'm optimistic that that's going to do well. It looks pretty good. The devices look good. Things that I didn't think Microsoft might be able to do, like really drive the power down so that when it's in this connected standby mode, it's like a smartphone. It sleeps and then it wakes up every so often, downloads your stuff, goes back to sleep again. And it did a great job on all those kinds of things. So computing, I think, is a big opportunity for us. And obviously on the tablet side, ARM's kind of the big dog right now. There's a lot of iPads out here, and they're all ARM-based. Not our ARM, but it's that community's driving forward, and it's pulling the developer attention to that architecture. Okay, so you have smartphones, tablets, and computing, and I think the whole computing thing will continue on. You'll see ARM-based servers, you'll see high-performance computing eventually, you see all those kinds of things going on because it's just the power efficiency of doing that. For us, the next big thing is really we're going to try and drive the massive change to the way the network is laid out. And the reason is we had one of the operators come in and say, we were talking about 10 to 12x increases in data demand. They said, no, 1,000x.
Yeah.
And we said, 1,000x, huh?
Yeah.
And we had been working on these small cells and interference management, but we had really been thinking of it more like you think about a femtocell today. If you don't have coverage in your house, you put it down. And when you start thinking about 1,000x, you're like, no, that's the way the network gets rolled out. I mean, you essentially want to have one cell site per phone. The other problem is 1,000x, how are you going to get 1,000x revenue? You're not. So you really got to go after the cost side. So we said, okay, we're going to build phones that are cell sites that are basically the cost of a phone. So that's a cell site now. It's basically built with a lot of the kinds of technology that a phone is built with, except doesn't have a screen, doesn't have that much memory, doesn't have a big battery. Some bunch of stuff's missing. So it's probably cheaper than a phone.
Wow.
Right. So now you're going to have these.
The base station is cheaper than the phone.
Base station is cheaper than the phone, and that's kind of the future. And then you can ad hoc deploy them, just plug them into the wall, plug them into your Ethernet or Wi-Fi or whatever. Whatever you want to do to get the backhaul. And there's lots of different ways to deal with the backhaul. So that's going to be the next kind of cool thing is these things kind of go everywhere, and then they're gateways
And let's define this for folks who don't know what we're talking about. Femtocells are defined in the sense of being closer together.
Yeah, closer together.
You said one per phone. What are you seeing?
Well, this will be like one. These things will be able to be like one per phone because they're so cheap.
But there's probably a transition where a femtocell represents some number of phones that are smaller than today.
Yeah, I mean, so most femtocells do, 8 calls or 16 calls simultaneously, and there's other types of small cells that'll be outside that'll do 64 calls or.
And how do you go through New York City doing femtocells? I mean, where do you place all these?
So you're still going to have the macro. It's still going to have the umbrella coverage, but these will be in everybody's house, and they actually leak outdoors. That's what's really interesting is that we did a thing where we took these and put just 7 of them around the Qualcomm campus inside. We did our normal drive route that we use to test technologies, and they're covered by these things. And this doesn't even put out a lot of power.
Or it's 900 or
this this one is probably running. I think we're doing it in AWS right now. I'm not positive, so it's. What's AWS? 1.3.1.4.
It can be higher because you're not trying to go long distances.
Right.
And still energy will
goes
leak
to the
out.
building.
Yeah.
To the wall.
Yeah, it's funny because these things will actually cover outside, but they don't necessarily cover floor to floor in a building. So you're going to have them in a bunch of different rooms and so forth. And you want that anyways because you want to have the capacity of this sector allocated to your phone.
And you can have some outdoors, obviously, as well, so that they cover poles or whatever.
Yeah, you'll want to have outdoor coverage.
And one of the key things, since we're trying to go to very high data rates, if you have a high data rate and a long distance to go, you have to provide a lot of power.
Right.
Whereas if they're close by, much, much less. And so that becomes very critical.
In these?
Yeah.
Having these close to where the phone is.
Power in the phone itself?
Yeah, if you get the network and the
so
phone
the battery life
closer,
goes up because you're at a...
goes up. Well, I mean, it's dependent on the data rate. You could also just pump more data, too. But for the same data rate, the power goes down pretty dramatically.
Data rate.
So that's kind of the next big thing. And then we look out farther into things like, the kind of the Internet of Everything and sensors that you might wear on your body or sensors in the environment around you and the phone interacting with all those sorts of things. So we got a lot of really interesting projects along those lines. And, I've been doing things like, trialing different kinds of sensors that people have right now. Like this is the Nike band. I wore this Dexcom sensor. It was like, I always have stuff in my pockets, So this thing's like a continuous glucose monitor. I wore it here for a week and just, watched that.
No kidding.
Super interesting stuff going on. Now,
how does it get the information?
It's got a little needle and it went inside. So, your average person not going to do it. But somebody with diabetes, I think so. And then this one talks to a dedicated device, but as soon as we get the FDA to play along, it'll just go to your phone and your phone will take, keep track and then backhaul it to your healthcare provider and so forth. So, but really interesting. I mean, you see interesting things by continuous monitoring instead of just, pricking your finger every once in a while. So that stuff's going to happen in the future.
You've got to talk to our buddy Keon when you get back home to San Diego because he's working on integrating all this stuff.
He's working with us, actually.
Okay. Now, I want to do two things at once. One is I want to talk about bandwidth, but I also want to talk about this question of how physically, I get the math, but what if these... So back to New York for a minute. I mean, easy to picture this in the apartment window or in the window of an office.
Yeah.
But are they just like this? I mean, they're literally...
No, they'll even be small. I mean, this is,
are there issues? Are there radiation health issues? Are there transmitter tower issues?
This puts out less than your phone does.
Less than the phone.
It's 10 milliwatt
And it's not
transmitter.
close to your ear.
Yeah, it's not anywhere near.
So,
but,
and that's one of the problems.
It actually improves the situation.
Because you're transmitting
Because your
lower
phone is
power.
not trying to reach...
The phone is sending
There
less
we go.
power.
But by the way,
That's a
there's
huge
no
selling
evidence
point.
that that's a problem. I just want to get that straight,
Okay.
too. No, I mean, there have been a lot of studies done now.
We actually have spent years looking at this.
Yeah.
And we'll talk about it over a beer later.
And you can't prove anything is safe.
Yeah.
And so using less power is always going to be positive,
Right.
even though it may not be hurting at the power level. Certainly isn't right now at the power levels we're using.
Right.
But as you go to higher data rates, the power goes up.
Yeah.
But typically
Same
you're holding
distance.
it like this, in your hand or something.
Yeah.
But still, the FCC wants to make sure you,
Oh, that's good.
certain amount of absorption and so forth.
Now, one of the really fascinating things to me is the convergence of the race for broadband prominence between the whole Wi-Fi story and the cellular story. How do you see this? What's
Totally complementary. I mean,
are they? So I mean, the guys. I know guys in Wi-Fi that say, oh, we're gonna just win this thing. It's just all gonna be Wi-Fi. The phone will use Wi-Fi, and
okay, they've been saying
You're not
that
buying
for,
that story.
Well, I mean, they told us 3G wouldn't happen because of Wi-Fi too. So I mean, these things are complementary. And when I talked about the 1000X, offload is part of it. But you have Wi-Fi is running in unlicensed bands. It can only go very short distances, and anybody can interfere with you. The key to make this stuff work is that they actually work cooperatively in licensed bands and manage the interference between them. And that's why you can get these really high rates. So
And hand off readily.
yeah, that's right. And
Because if you're moving, you've got to be able to handle that.
yeah,
Right.
So Henry Terry was just talking about some of the ID loss differences when you go back and forth.
there's some of that. Yeah, I mean, you got to handle that at a higher level in the stack and so forth. But but we do that. I mean, we see, and we always have seen Wi-Fi as complementary to cellular. Licensed bands do certain things very well. Unlicensed, it's nice because you don't have to wait for an operator to say, yes, you can put that on my network. So that certain things can go faster there, and it's great. I mean, having both is really good, but one is not going to eliminate the other, I don't think.
So when people talk, I'm sorry.
No, it was interesting. A number of years ago, I took a little bit of heat because I had said that there's not a good business model for selling Wi-Fi. being able to charge for it and pay a monthly or whatever, because very shortly, the cellular carriers are going to give you a single price for data.
Yep.
And so why pay both?
Yeah.
And so what Wi-Fi is involved to is a backup, a handoff.
Right.
And so it works very well that way. It may, in fact, depend on whether you're using cellular bands or Wi-Fi because of the handoff being easier with cellular, but with these very small cells.
I think your bet paid off.
Yeah, it worked out okay.
I would much rather have owned Qualcomm stock than Boingo or anybody else. So,
And there's 1.7 billion 3G users now in the
Right,
world today,
right.
so it's okay. It's
Right,
working well.
Right. So let's talk bandwidth then for a minute. How does this scale up? What are we going to see? I guess two questions. In the U.S., now we're in this kind of weird situation, which I'm not used to yet, where we're rolling out LTE ahead of Europe, ahead of a lot of folks. We are actually, kind of surprisingly, we're in a fairly advanced position in the United States. I'm not comfortable with that situation. I'm used to being number 23 on the OECD list, or whatever we were a few days ago. So, but aren't we about to kind of, thanks to LTE, really be global leaders?
I mean, I think we were global leaders even in the beginnings of CDMA. You know, okay, it did roll out in Korea and Hong Kong, but U.S. rolled that out pretty quickly too. And a lot of people in the old days said, oh, well, Europe was ahead because they were doing a lot of SMS messages. At the same time, we were already on the internet with our device. I mean, we started doing that in 1998. But we couldn't get through, we couldn't break that message out to mainstream. Everybody just believed we were behind.
But I'm talking about broadband.
Second generation TDMA was rolled out much faster elsewhere.
Yes.
CDMA came along a little later.
Yes.
But then with 3G, in fact, the U.S. was ahead because we had nationwide networks with 3G
So I'm not being,
before others.
I understand.
And
Okay?
actually
And that
now,
covered the
about
data.
this.
yeah, but now it's not just LTE, but also multi-carrier WCDMA that's rolled out. So T-Mobile, for example, their 4G service is done by concatenating multiple WCDMA channels
Right.
together instead of having one wider
Right.
LTE. But it's basically the same.
It's
I
still
mean,
what- yeah.
we kind of hit the limit of what we can do in terms of getting any individual radio link,
Yeah.
the bandwidth up. We hit the Shannon
Yeah.
limit. So LTE, from an efficiency standpoint, is basically the same efficiency as WCDMA.
Mm-hmm.
And therefore, when you run an LTE system with 10 megahertz or you run a WCDMA system with 5 next to each other, it's roughly the same thing. So different carriers have gone different ways. But
And-
You guys
and
are
in
radio
fact-
guys, you kind of tell us.
Yeah. And in fact, one of the
sorry,
things to
you
think,
can all wake up now. There's coffee outside.
but one of the things you want to realize is that there are many different frequency bands around.
Yeah.
And you may be able to get a piece of spectrum
Yeah,
at
yeah.
one frequency, another piece at another.
Yes.
Being able to use both at the same time to get high data rates
Yeah.
is actually a tremendous advantage. So
Right.
the multi-carrier is going to be around.
Yeah.
Yeah, that's big.
But what I was shooting at was that we've kind of just crossed this Rubicon moment where we're getting more bandwidth in the United States from our handsets
Right.
often than we are from the landline guys. And that's a huge thing. So the landline guys were number 23 and still are in many places as far as the OECD rankings are concerned, but we've just jumped way ahead with wireless.
Yep.
Now, I'm sure that fight will go on, but maybe I shouldn't call it a fight. The equation will go on.
Well, I mean, if you look at a thing like this, actually, wireline bandwidth is going to be important. We're going to need to, improve
Backhaul.
because
Backhaul.
the backhaul today that a carrier worries about goes to their cell site.
Right.
In the future, it goes to their customers' premises.
Right.
So there's actually a very interesting synergy that's going to happen between wireless and wireline
Yes.
going into the future. And you can think of these as basically being the thing that just spreads the bits out to a bunch of devices that you have nearby.
Yes.
Right. But it gets there through a very confined.
And that's the
spigot.
equation we're talking
Yeah.
about. Yeah. So you've got to have both.
You got to have both.
Yeah,
Yeah.
yeah.
And by the way, we will do wireless backhaul with these things too. But
Right.
There'll be high-frequency radios, for example, that provide the backhaul as well.
yeah, all sorts of.
You know, a lot of different ways.
Yeah. We actually have a county, we're trying to put in our county a global class, 100 megabits to the residents, fixed wireless or wireless. So I'm going to call you later and ask you for your advice because we may end up trying to create something which is the best in the U.S. at least.
Yeah.
And we'd love to take a few arrows and get it right and be.
Well,
be able to
we
get that
know some guys that are doing microwave, really low cost microwave, and you could get
Yeah.
very high data rates out of that.
Okay, that's
so
exactly what
really
we're doing.
interesting opportunity.
So to kind of summarize that run of thought, it looks to me like whether you use LTE or WCDMA and multiple channels and so on, we are in that moment now in the United States where we're receiving or using ever higher amounts of broadband, almost unexpectedly coming from the wireless world instead of from the wired world. And that's great. And as far as I can tell, that's the future. I mean, does that feel right to you?
Say it over a few more times.
Yeah.
Sounds good.
Well,
So
it's
broadband is going to come from wireless instead of from...
By the way, we are a path. There are more mobile broadband subscriptions in the world than there are fixed broadband.
Oh, yeah,
already.
yeah.
More smartphones than there are PCs already.
Right.
And now you think it's doing that here, which is a developed country. Now think about rural Africa. Think about India. Think about the emerging markets. I said earlier there's 1.7 billion 3G subscriptions in the world. Half of those are from emerging markets, and we're basically going to double what we have today in the next few years. I think by 2016, another 1.6 billion just in the emerging markets.
Wow.
So they're going to have all of this bandwidth.
Yeah.
We just launched with Bharti Airtel, who's working with us in India, just launched LTE there, and so they have a big fat pipe going to the people there, and they will leapfrog what the whole fixed internet era that we went through.
Yes.
But they don't have that investment to worry about. They might as well go to the latest thing.
And will they use wireless backhaul?
Yeah, they'll use wireless. They'll use, and there are
the whole
fiber
thing is
loops
wireless.
there.
Satellite.
There are fiber loops there. There's for the rural
Outside.
areas of satellite. I mean, it'll be all sorts of stuff.
Yeah. Is the cost basis of this reasonable enough that you can go into a place in an emerging world and it's not prohibitive? It's not just requiring some huge amount of outlay.
Costs less than a phone.
Yeah.
One story I like to tell.
Say it 10 more times.
We have a wireless reach program where we're trying to do social things using wireless phones around the world, different projects with local partners. And one of them we set up early was a microfinance, a village phone, where we provided a box with a phone, tall antenna, extra battery, marketing materials, an agreement with a local carrier, and people could go out and sell phone time, airtime.
Yeah.
Now you can't do it anymore because everybody's going to get their own phone.
Yeah.
So we had to add a lot of additional services to that,
Sure.
such as banking, et cetera. And so the women, largely, who are doing it are still successful entrepreneurs, but you can't just sell cell phone service because that's something everybody wants as soon as they get a little food in their mouth.
Isn't that amazing?
Yeah. Well, I mean, another cool story along those lines is there's a Chinese company selling solar panels to rural Africa. And it's paid for because in the village where most people are, they don't have power. So they would have to go somewhere to a village, pay somebody to charge their phone, leave their phone there for a while, come back and get it. And the cost of paying for it and the time off from doing whatever they were doing actually pays for them to get this solar panel. The solar panel is there to charge the phone. Well, guess what? There's a little extra juice left. They run an LED light so they can read at night.
Yeah.
I mean, it's the coolest thing. All these interesting things happen because people got cell phones.
And what I've seen, GDP goes up as this happens.
GDP definitely.
Yeah, there was
goes
just
up.
a story in the New York Times about young women in India getting married, and they have to go to another village, the husband's home, and in fact change their name. In the past, they've just been completely isolated. The best present they get these days is a cell phone that allows them to stay connected with their original family, their own family, and that it's making a significant difference in their whole lifestyle. And so ways that you just don't even think about are fitting into different cultures and making a major difference.
Right. I've seen some of the guesses, but I'd like to have your views on the smartphone versus feature phone story.
Feature phone?
Feature phone,
Yeah.
So I think today rough numbers are 40% of global sales or so of the installed base are smartphones. And the question is, I guess, how are we to see that meter move?
It can't be installed base because there's.
No, it must be per year sales.
It must be
now.
unit.
Yeah.
It's unit sales. I'm trying to remember. Okay, so it's.
Well, in the
it's
U.S.,
something
it's
like
way
that.
over.
35 or
Yeah, if
40.
you
Way
look
over
at certain
50%.
operators, they're selling like 90%
Yeah.
smartphones. I think it was somebody gave me a factoid. It was like O2 in Germany said 90% of their
Right.
sales.
And I think over 50% of the phones in the U.S. already are smartphones.
it could be, yeah.
So in terms of sales per year, units per year, going forward, how fast does that meter move?
Well, the
Globally.
prediction that we just saw, most recent one, is 1 billion smartphones sold in 2014. It was 2015. They moved it in a year. 50% go into emerging markets. And the feature phones are, I don't know, what are we at? 161. I don't keep track of the GSM phones that well, so I'm not sure what the total number is, but maybe 16, 17, something like that, maybe.
I've seen like 5 billion phones out there.
No, I'm saying
no.
yearly sales.
Per year.
Yearly
Okay.
sales.
Yeah,
Yearly
7 billion connections.
Yeah, okay. Connections.
Yeah, I don't remember what the
People
total
have
is, but
multiple.
it's a substantial fraction of the phones.
I guess one reason I'm asking is in the work we're trying to do, we look at this question of how soon will smartphones be readily available on a common basis without cost prohibitions, no matter where you go. It just strikes me that the advantage to advertisers and so forth is strong enough that there won't be a price-based reason why smartphones won't be the phone du jour for everybody. Does that sound right to you?
I think the big issue is the emerging markets, just trying to get down to the very bottom of the economic pyramid. So, a lot of people in the bottom of the economic pyramid are getting refurbed, feature phones and paying almost nothing for them. And so we are, we'll break the $100 barrier this year, and then it's a question of, when do you get to 80, when do you get to 50? A lot of that's going to be driven by the cost of the display, honestly.
Display is the cost.
Yeah, battery, display, those are the things.
And by the willingness of advertisers of some kind.
It could
to take care of that cost.
Actually, so an interesting thing that just happened in Brazil, we just signed an MOU with the government of Brazil, and they want to lower the cost of smartphones there because it's a digital divide issue. They have a lot of government services that are available over the web.
Yep.
And we did a deal with them where the government is actually going to do sponsored connectivity, meaning if you have a smartphone and you go to a government website, you don't pay anything for that. So it's like an 800 call except for data. And we think that is going to happen, that other websites, in fact, Google's doing some of this in the Middle East right now with one of the operators where they have certain services that they pay for once you connect to those services.
So I hear you saying the word yes.
Yes, I'm saying the word
Well,
yes. That'll happen.
Yeah, this decade is the decade also that education finally is going to transition over to making effective use of technology. And of course, it's the mobile technology, 24/7 learning, et cetera.
Yeah.
And so that's going to be as important in developing countries, and governments are going to try to find ways of helping subsidize both the device and the airtime.
Right.
But it's going to save money in the sense that it's a much more efficient way to deliver education.
Right.
Not
I want
to
to talk to you
mention
more
health.
about that later. We're hard on that one, as you know. Just a quick touch on the peer-to-peer thing. We talked about mesh before. I know that it's been in the lab for a while. It's something which keeps coming up whenever you see an emergency situation, a hurricane strikes or whatever. All the cell towers are down, Haiti, and so on. Are we at a point now where you can say by a certain time, certain in the future, we think we'll have the ability to have peer-to-peer or mesh networks? Or
Yeah, so we're doing various things right now. We have a software platform it's an open source thing, so everybody can get access to it. But that uses the existing peer-to-peer technologies, just makes them easier to pair up. So it can use Wi-Fi Direct or Bluetooth, and you can run on different platforms and stuff like that. And that does the authentication and all the pairing automatically, so you don't have to type in numbers and all that other kind of stuff. So the software layer is there today. That's starting to be used. Then we're building new hardware. In fact, there's a thing in the standards body right now for peer-to-peer where we're augmenting LTE to have beacons. And what the beacons do is they actually, instead of just saying I'm a wireless service, they actually say I am something. It has a name. It might be I am a coupon for McDonald's, or I'm a connection to the internet, or I'm a display with this resolution, or I'm Mark Anderson and this is what I'm interested in. And at a very low power in the physical layer, the phone actually detects these things. You say, I'm looking for these set of things. And in the physical layer, it actually doesn't wake up the phone unless it sees something that you're interested in. And so that, I think, is the future, that you'll walk around, your phone will just kind of be in this environment where it's getting all sorts of offers, and you just detect the ones that you care about and then completely ignore the ones you don't. And that'll all be peer-to-peer.
And I want to take that from the old idea of location-based advertising to what I think I hear you saying, which I would call, in a military sense, situational awareness.
Right.
And that device becomes a situational awareness device. Is that fair?
Absolutely. I mean, it knows all the stuff that's around. It really will merge cyberspace and physical space.
Now, this is pretty cool.
You know, this is.
I mean, you know,
that's the vision.
in a world of cool things, it's pretty cool.
Yeah, I mean, so the vision that we've been working on for the last, I don't know, decade and a half was this convergence vision. Our next vision is actually from the phone, all the R&D that went into the phone to drive the cost down is going to mean that those chips and chips like them will go into, you know, all the stuff that's around us, and then the phone sits in the middle and listens to what's around it and allows you to sense and control and interact with stuff that's around you.
Wow.
So we're spending a lot of effort on that.
That is so cool.
It's going to be fun.
And think about the privacy security issues. So
Yeah.
there's lots of work to be done.
No, you guys have to think about that.
No, we are. We're working. I mean,
All right.
you know, it's always the
Yeah.
cat and mouse game,
Yeah.
but
I think that again redefines what is a telephone.
yeah,
It's not just a computing device, it's a situational awareness.
it's another sense for you.
Yeah.
It's a new sense.
Not a sense, but 15,000 senses.
Yeah.
All right. We have 5 minutes. If there are questions that you have, please come up to a microphone, identify who you are, and fire away.
Stephen Sprague, Wave Systems. So could you comment a little bit, you talked a little bit about Windows RT, you just commented on security. There are obviously interesting things that are going on right now in the mobile space, driven both by Microsoft and by others, to provide much more trustworthy execution in the handset and ultimately within the processor architecture. And that might be interesting just to hear some commentary on as to, I think that really moves beyond some aspects where the PC is and what's going to be possible.
Yeah. So we're building a lot of hardware into the chipsets to enable, you know, trusted boot and all sorts of trusted computing aspects. And Microsoft is very focused on it with Windows RT. And there are people who complain, oh, they're being restrictive relative to what was there in the past, but you know, they really are focused on making a new environment that is much less susceptible to malware and all the other stuff that we've seen happen in the past. And so this new Metro environment that they're putting on, they're putting on Windows, but in Windows RT, it's really the focus for that. You know, I think that's going to be a big positive, but it'll take some adaptation. People have to get used to the fact that they will develop in a certain way, but consumers and enterprises will be a lot happier because they're not going to deal with the same issues that they deal today with their existing Windows devices.
It's interesting. From the very early days, Qualcomm has always had a government operation, small compared to commercial, but very important. And one of the areas that we've always been interested in is the whole issue of privacy, security, et cetera. And so that then can train people are then available to help on the commercial side as well.
Well, I know Stephen feels this way, and I feel this way, and we've talked about lunch today about this, but I really think you guys have a different window open to you, unfortunately, by this concern over nation-sponsored theft of IP. And if I were a CEO of GE or any large company...
Of Qualcomm, too?
Yeah, Qualcomm, too. I would be concerned all the time about not just BYOD, but even if I was able to hand out devices, which devices would they be, and what would I do to make sure that they really work properly?
But I mean, it's not even the devices. It's people attacking our systems all the time.
That's
and,
right.
You know, one of the key things we do to combat that is we just run really, really fast. So even though they get something, we're over here when they're here.
Well, try it when you're Boeing and you're making 10-year-long
No,
airplanes.
I get it. Our cycles are
I
very
think we've
short.
got somebody here.
Hi, Nelson Hiller Results Group. You mentioned your wireless research program, and Mark mentioned the aorta always-on real-time access. Can you say a little more about what you're finding out about education using wireless, and also about what, in fact, would make the cost of the connectivity come down, because that's really been a killer.
Yeah, big problem. Yeah, about 5 years ago, one of the programs we started was with 4 high schools in North Carolina, and we equipped one class in each high school with smartphones. Of course, not as good as today's smartphones, but originally we're starting with teaching Algebra 1 and then went on from there, and we helped with some curriculum materials, training teachers, students, making sure they felt comfortable with the phones in the classroom as opposed to trying to keep them out. And it was interesting, at the end of the first year, there was one school in particular with a very good teacher where she had one class with the phones, one class without the phones. The class with the phones, 100% of the kids passed the statewide exam on algebra. In the class without, which was otherwise similar, only 2/3 passed. And so they began to wonder, what's going on here? Why is it working so well? And looking further, it turned out it was the 24/7 aspect, that the kids had the phones at home, they tried to do a homework problem, run into trouble, they can get on the web and check with the others, social networking. And then the kids that were coming up with good solutions would video themselves and send it around, and so they became teachers. And the last time I was there, one of the teachers said that he now devotes half his classroom time to students presenting their solutions, the inverted classroom in a sense, and he can work with the persons that are having more trouble. So that aspect of it is off to a very strong start. The issues of cost, I don't think it's the device issue. The device costs are coming down, and they're becoming more manageable. The airtime costs is another issue. The FCC did set up a program a year ago, maybe a year and a half ago or so, where they provided $10 million. There were 19 school districts and one library that won ability to try the system out with subsidized airtime. And those results are just being evaluated. This North Carolina group is one of the ones that are involved there. But it appears, at least from early results, that's been very positive. But I keep telling you, forget the one laptop per student in the classroom. That's not the way to go. It's one smartphone or one tablet per student, 24/7. Give them some airtime availability, and it really does make a major difference.
We've hit I see our little red light flying here, so we have to bring this to an end. But I can't tell you how appreciative I am that you were both with us, and thank you for sharing all these different ideas.
Thanks. Thanks for having us.
And I have, Paul, something that we don't do every year, but we have done it before, and that is, thank you, well done. Our last recipient was a brilliant guy in wired and wireless broadband, so there's a good precedent here.
Okay.
And the guy before that was the guy who just fired the rocket 2 years ago, Elon Musk. And we would like you to accept our CEO of the Year award.
Wow.
Totally heartfelt for doing a great job building a terrific company with some help in the beginning, and doing it in a way which would allow me to tell my own kids, here's somebody I'm proud of.
Thanks very much. I really appreciate it.
Congratulations.
Thank you. Had a great role model.